class coaching. Previously, we have seen number of topics, techniques, and problems. Today, we are going to see about the antenna fundamentals in detail. Okay. So this is one of the topic which is coming for the GATE exam. Antenna fundamentals. Okay. Yeah. So before we are going to know about antenna concept, we have to know about the fundamental concept. Okay. What are the topics they have given in the syllabus? Apart from that, you have to know about the basic combination of antenna fundamental concept. Okay, so before we are going for our antenna concept, just we'll see about the backbone for the antenna concept. Okay, generally we all know that our communication is going to be classifying into two types of communication based upon channel. Based upon the channel, the communication is going to be categorized into two types. One is going to be wired communication and another one is going to be wireless communication. So our antenna placing a major role in the part of wireless communication. Keep it in mind. Okay. While coming back towards your wired communication, definitely there should be a linking between our sender and receiver. Okay. The sender can transmit the information to the receiver for the proper channel with the help of the proper cable. Okay. The wired communication started with the help of open wire cable. Previously, we have used the single line cable for the transmission of energy. But recent advancement, we are going to use the number of wired cable in the case of wired communication. So secondly, we have used the open wire cable. Okay, still we are using the open wire cable in the concept of telephone. We are going to use the open wire cable. And later, third, we are going to use the twisted pair cable. Okay, generally we got the error like in twisted pair cable, it's going to be called as crosstalk. Okay, the crosstalk is going to be existing in the case of twisted pair cable. And next we are going to see about the another cable is going to be called as coaxial cable. Okay, so still we are going to use the coaxial cable in the form of cable TV reception. Okay, and while coming to the coaxial cable, we have the core and cladding material and wire-like structure. Okay, in between we have the cable-like structure is going to be called as dielectric media. Okay, so inner we have the core, later on we have the cladding, over that we have the wire-like structure. Okay, with the help of this we can able to easily transmit the signal from the sender to receiver. Okay, and finally in wired communication, the recent era which we are going to use in the case of wired communication is going to be called as optical fiber communication. In the case of optical fiber communication, the signal energy is going to be following as like our free space energy. The termed are 3 into 10 to the power of 8 meters per second. Okay, in that way, in that case, we are going to transmit in the energy. Okay, so in optical fiber communication, all the signals are going to be converted into light energy, and with the help of the proper medium, we are going to transmit in the signal from sender to receiver. Okay, well, compared with the wired communication and wireless communication, we can able to find out the major drawback in wired communication. Okay, because in wired communication we could not able to transfer the signal for long distance. To transfer the signal in long distance, we ultimately use the wireless communication. Okay, so in wired communication, for local area, for local use, we can use the wired communication concept. But in the case of wireless communication, we are going to use in the concept of electromagnetic energy. Do you all know that what is electromagnetic energy? Yeah, electromagnetic energy is nothing but having both electric and magnetic field, both are perpendicular in nature and perpendicular to wave propagation. It's going to be called as electromagnetic wave. So in the concept of wireless communication, the signal which we are going to transmitting for your sender to receiver by means of electromagnetic signal. Okay, the conversion of electrical signal to electromagnetic energy can be possible with the help of this antenna concept. That's what your antenna will be placing a major role in the concept of wireless communication. Okay, hope you are able to understand. Clear? So we all know that the communication is going to be classified into two types: wired communication, and what are all the wires we are going to use in those cases we have discussed. And in the case of wireless communication, so with the help of long distance traveling of your signal, we are going to use the wireless communication. There the antenna will be acting as a major role. Okay, so this was about the antenna concept. Okay, now we are going to see about the basic concept of antenna. This what about the first slide. Okay. 1 second now. Yeah. So generally, the antenna is nothing but simply whatever it may be the given definition. You don't follow this. I'll tell you what is antenna. It is an ordinary elevated conductor. Keep in your mind, it is an ordinary elevated conductor which radiates and intercepts electromagnetic energy. Which radiates and intercepts the electromagnetic energy is going to be called as antenna. Okay. The another name we can have the antenna as EM radiator. EM radiator, that means it will radiate the electromagnetic energy. That's why it's called as EM radiator, electromagnetic radiator. And sensor, it's a very good sensor. We can consider our antenna is going to be a very good sensor. By means of sensor, with the help of antenna, we can able to find out the temperature of the region. Correct? So the name of antenna is going to be sensor. With the name of sensor, the antenna can able to find out the temperature of the region. Next, the third term, which we can frequently call it as transducer. You all know that what is transducer? Yeah. Transducer is a device or equipment which will be converting a type of energy into another type of energy. It's going to be called as transducer. Okay, wow. Another name of your antenna is going to be impedance matching device. Yeah, impedance matching device. It will matching the impedance between the free space medium to cable. Cable to open, that means cable to free space medium, it will be covering. That's why it is going to be called as impedance matching devices. Okay, wow. So whatever it may be the definition, you have to concentrate over that. Your antenna is going to be an elevated conductor which radiates and intercepts electromagnetic energy. And following that, we have the variety names of antenna. The first name is going to be called as EM radiator, sensor, transducer, impedance matching device. These are the variety names given by your antenna. Okay. With this slide, we can able to get what is antenna and what are all the parameters and what are all the other names of antenna we have discussed. Okay. Next, we are going to see about the next slide. Yeah. Transmission and reception of antenna. Okay. So generally, for the communication, we need this generator or transmitter, and the other we are going to concentrate over the transmitting antenna. Generator or transmitter. That signal is going to be passing towards your transmission and cable, and finally we can have the transition region or antenna. Okay, that's going to be called as flared. When we are going to flaring the transmission line or the waveguide, we are going to get your antenna concept. Okay, this is what mainly you have to concentrate. Okay, that's going to be called as tapered section. With the help of generator, all the process have been done. Okay, it will generate the signal, it will do the modulation with the help of the concept like mixer and local oscillator, and finally of the proper power amplifier. Last, we are going to transmit the signal with the help of this antenna through with our transmission line cable. Okay, with the help of antenna, we can able to transmit our signal. On other hand, at the receiving end, we have again the first basic step is going to be called as antenna, transmission line, and receiver. Antenna, transmission line, and receiver. Okay, whatever the information we are going to transmit from the transmission side, the same information is going to be getting in the receiving antenna with the help of the plane wave. Okay, so in the case of antenna, the polarization is going to be placing a vital load. The polarization is going to be placing a vital load. As you know that the polarization is nothing but orientation of electric field with respect to earth. It's going to be called as polarization. Okay, generally we are going to use the circular polarization for our antenna wave propagation. Circular wave polarization we are going to use to transmit the signal from transmitter to receiver. Okay, it's going to be appropriate, or we are going to take the circular polarization concept for the polarization concept. As you know that the polarization is nothing but orientation of electric field with respect to earth is going to be called as polarization. As we have the number of polarization like linear, vertical, inclined polarization, we have the different types of polarization. Whatever it may be, finally we are going to take the circular polarization. Okay, we will radiate the energy in the form of circular polarization. And finally we are going to receiving the plane wave at the receiving end, receiving antenna that will receive the electromagnetic energy and given towards your TEM wave. TEM wave is something but transmission line wave. And finally the signal is going to be converted as electrical signal and the electrical signal is going to be given for the receiver. Okay, wow. The receiver can demodulate the signal and we are going to get the proper output. Okay, wow. This what about how your antenna is going to be working in wireless communication from transmitter side and receiver side. Whatever it may be, the last step of is going to be antenna, and at the receiving end, the first step is a vital role. Without antenna, there is no wireless communication. That you should keep in your mind. Right? Without antenna, there is no possibility of wireless communication. The wireless communication are mainly used for the conversion of signal for long distance. Okay, that's what about your transmission and reception of antenna. Okay, can you able to get it? Yes. With the help of transmitter, we are going to sending a signal with the help of antenna, and at the receiver, we are going to get the signal like our plane wave, and we are going to converting that into receiving end. In receiver, we have the demodulation, and in generator, we have the transmitter. Sorry, generator, we have the modulator, and receiver, we have the demodulator. So for proper modulating and demodulation, we are going to get our signal for the long distance. So this diagram shows you that how the signal is going to be transmitted and how the signal is going to be received with the help of the antenna concept in the case of wireless communication. Hope you understood what we told. We discussed about what is wired communication and what is wireless communication. In wireless communication, what is the major role of antenna? And we know that what is antenna. Antenna is nothing but ordinary elevated conductor which radiates and intercepts the electromagnetic energy. As it has a number of names called radiator, sensor, transducer, and impedance matching. Okay, with this we'll go for the next concept. Okay, yeah. So this how the antenna is going to be radiating energy from the antenna towards the free space. Okay, wow. Do you all know that what is the free space impedance? Anyone? Do you all know that what is free space impedance? Yeah, it's nothing but 120 pi. Keep in your mind. Frequently they will ask you what is the free space impedance. 120 pi. Okay. So this diagram shows you that how the AC signal is going to apply towards the transmission line, and it's going to be tapped at the end where the antenna is going to be formed, and finally it's going to be transmitted to the free space. We can also say that free space impedance is going to be 377 ohm or 120 pi. Keep in your mind, ma. 377 ohms or 120 pi. Okay. So with the help of this antenna, we are going to get our electromagnetic energy. So both signal, electrical and magnetic signal, are going to be mutually perpendicular. Okay, wow. Next, we will see about the basic functions of antenna. Yeah. An antenna may be piece of conducting material in the form of wire, rod, or any other shape which excitation. An antenna is a source or radiator of electromagnetic energy, as we know that. An antenna is a sensor of electromagnetic waves. An antenna is a transducer. You all know that. An antenna is an impedance matching device which will matching the impedance of the free space to device space. It's going to be called as impedance matching device. And sixth one, an antenna is coupler between a generator and space or vice versa. A coupler is nothing but it's going to be called as balloon. Lema, coupler is nothing but balloon. Balloon is the full form of balancing and unbalancing unit. For that purpose, we use the antenna. So antenna is the device which we are going to use these many functions. It's going to be called as antenna, basic functions of antennas. Okay, wow. Next. Okay, with this slide, with this PPT, with this we can able to get that what is functions of antenna. Next. So applications, we can come to application. We are going to use the antenna for variety of applications. Okay, wow. Used as a transducer, matching direction device, and temperature measurement device. So apart from that, in wireless communication, we use the antenna for wide variety of applications like our satellite communication, cellular mobile communication, Bluetooth communication, and Wi-Fi communication. Apart from that, we can use the number of communication as the part of wireless communication. Okay, this is what about the applications of antenna. Okay, so as I told you, whichever the topic they have given you in GATE syllabus, whatever it may be, you have to know about the basic fundamental concepts of the antenna. Okay, wow. So it's very important, not only for antenna concept, for all type of wireless communication like our satellite, cellular mobile, Wi-Fi, Bluetooth, and etc. We can have that concept for the proceeding. Okay, va? So the parameters of antenna is going to be called as radiation pattern, beam solid angle, radiation intensity, beam width, gain, directivity, impedance and radiation distance, polarization, antenna effective aperture, and antenna temperature. Okay, wow. These many concepts are very much clear, so that you can get the clear knowledge about the antenna. Okay, wow. So as a part of that, you are going to read about the gate coaching, gate syllabus. Yeah. So not only gate, they are going to ask the question from antenna wherever you go. Generally, if at all, if it's going to be a core like company, definitely they'll ask the question from antenna, because it's going to be a main part of wireless communication. They'll check as an EC student, you have to know about. So they'll check your ideas. Okay, they'll check your concepts, what you understand about the antenna and wireless communication. Okay, wow. So don't think that antenna and wireless communication is separate. Wherever you are going to get the questions like your wireless communication, definitely there will be a question like your antenna. Okay, wow. Hope you understood. Okay, so these many parameters of antenna: radiation pattern, beam solid angle, radiation density, beam width and gain, directivity, impedance and radiation distance, polarization, antenna effective aperture, and antenna temperature. Now we will go and see about one by one, and each and every one should have the formula. Definitely you should keep the formula in your mind, so that if any question from gate or any other exam will arise, definitely you can get the proper answer. If the formula is going to be correct, definitely you are going to get the proper answer. Okay, wow? That's what. Parameters of antenna, these many concepts. Yeah. So before we are going to see about parameters, we will see about the simple antennas which are going to be using. The simple antennas constituting about the isotropic radiator, direction coupler. Okay. The first we are going to see about isotropic radiator. Okay, wow? So your isotropic radiator, but it's a reference antenna. Keep in mind, your isotropic antenna is going to be a reference antenna and is defined as hypothetical and crossless antenna having equal radiation in all directions. Okay, wow? So isotropic antenna is something, but it's a reference antenna and it's defined as hypothetical lossless antenna having equal radiation in all directions. Okay, wow? Although it is an ideal, not physical realizable. It's an ideal. Okay, we are going to take this. Okay, wow? It's often taken as reference for expressing directive properties of antenna. That's what about your isotropic radiator. Next, direction antenna radiates energy towards desired direction. Okay, wow? Which will radiate the energy towards the desired direction. It won't radiate the energy towards all the direction. It's going to be called as direction antenna. Another name, it's the one having the properties of radiating and receiving other direction than the other direction. It's going to be called as directional antenna. Okay, wow? Keep in mind, it will radiate the energy or receive the energy towards a particular direction. Hope you understand. What is direction antenna? First is going to be called as isotropic radiator. Second one is going to be called as directional antenna. Okay, so isotropic, I told you already, it's a hypothetical reference antenna. It's going to be taken for the reference of antenna. Directional antenna, also I told you, it's an antenna which radiates much power in some direction than in other direction. This is what about the direction antenna. And again we have the omnidirection, or simply we can call it as non-directional antenna. Okay, omnidirectional antenna, it's otherwise called as non-direction antenna. Okay, wow? It is defined as the antenna having essential direction in all directions. That is, non-direction pattern is given plane and direction pattern in any other plane. It is going to be called as omnidirectional antenna. An antenna which has a non-directional pattern is going to be called as omnidirectional antenna. Okay, wow? So what are the main three objects, main three antennas we discussed? Isotropic radiator, directional radiator antenna, and omnidirectional antenna. Okay, wow? Next we are going to see about the first topic, radiation pattern. Okay, wow? This one about the radiation pattern concept. Okay, wow? Antenna radiation pattern is defined as the mathematical function or graphical representation of the radiation properties of an antenna as a function of the space coordinates. Okay, well, generally the radiation pattern is nothing but a mathematical function or graphical representation of the radiation properties of an antenna as a function of space coordinate system is going to be called as radiation properties or radiation pattern. Okay, the radiation properties include power flux density, radiation intensity, field strength, directivity, phase and polarization. Okay, wow. We have the two types of radiation pattern. One is going to be called as field pattern. Another one is going to be called as power pattern. Okay, wow. One is going to be called as field pattern. Another one is going to be called as power pattern. Okay, wow. Now we will consider. We'll going to see about your field pattern concept. Okay. Yeah, these are the some views how the radiation pattern is going to be happening in the antenna. Okay, 3D views. Okay, next. So these are the lobes which are existing from your radiation pattern. Okay, yeah. Now before we are going to see about those things, we will see about the types of radiation pattern. There are the two types of radiation pattern. One is going to be called as field pattern. Another one is going to be called as power pattern. The radiation is expressed in terms of field pattern, then the radiation pattern is going to be called as field pattern. Okay, wow. And if the radiation is going to be taken in the form of power pattern, that means power per unit area or pointing vector is going to be called as power pattern. That you should keep in your mind. Generally, we have the two types of radiation pattern. One is going to be called as field pattern. Another one is going to be called as power pattern. Okay, wow. That's what. Okay. And come to the point of next concept. In this case, yeah. So this what about the pattern lobes and beam pattern widths available here. Yeah, this you can refer. Yeah, these are the radiation pattern, or we can simply call it as field pattern. Generally, this pattern having three types of lobes. Okay, one is going to be called as major lobe. Another one is going to be called as minor lobe. Major lobe, which occupies major area in the direction, is going to be called as major lobe. Minor lobe, the minor lobe is going to be classifying into two types. One is going to be called as side lobe. Another one is going to be called as back lobe. Okay, wow. We have two types of lobes. One is going to be major lobe. Another one is going to be called as minor lobe. The minor lobe is going to be classified into two types. One is going to be called as side lobe. Another one is going to be called as back lobe. Okay, wow. So while coming to the point of main lobe or major lobe, main lobe. So this diagram you can refer. In this case, mainly, yeah, you can see in this diagram, this one is going to be called as main lobe, which occupies major area in the radiation intensity. Okay, which occupies major area in the radiation intensity is going to be called as major lobe. Apart from that major lobe, the lobes are going to be called as minor lobe. Here you can see minor lobe. Yeah, can you able to see that? Yeah, the minor lobes are going to be classified in two types. One is going to be called as side lobe. Another one is going to be called as back lobe. Okay, back lobe effectively is very less, but side lobe will consume some energy. Okay, while coming to point of this major lobe, in this case we are going to find out two types of beam width. Keep in mind, ரொம்ப important. They will ask frequent questions from beam width of antenna. Okay, one is going to be called as first null beam width. Second one is going to be called as half power beam width. Yeah, I'll tell you how to take the first null beam width. Okay, so when the major lobe hits the very first portion of your intensity line is going to be called as first null beam width. See here, line from here to here is going to be called as first null beam width. Okay, so how we can able to find out the half power beam width? From the major, we are going to take the 3 dB minus, and there we are going to take the half power beam width. From the major lobe, from the maximum to, we are going to take the 3 dB, and there we are going to take the 2 points P1, P2. The distance between the P1 and P2 is going to be called as half power beam width. Okay, can you able to understand this one? In pattern lobes and beam width, we can able to understand these many concepts. Definitely you will get the question from this concept. In the case of antenna radiation lobes, we have the two different lobes, half power beam width and first null beam width. Okay, yeah, next one. So that's what here this discussed. Yeah, here you can see. Yeah, we have the main lobe. Main lobe, and we can have in the back lobe also. So those variant is going to be calculated with the help of the Cartesian coordinate system, theta and phi. And these are the formulae which are going to get from our field pattern. E theta n of theta comma phi is equal to E theta of theta comma phi by E theta comma phi maximum. Okay, well, this is the formula. And how this is going to be happening with the help of this antenna, they have been represented. And power pattern, PD of theta comma phi equal to 1 by 2 E of theta comma phi whole square by eta theta, theta into theta 120 pi free space impedance. 120 pi is the free space impedance, or we can simply say it as 377 ohm. Okay, intrinsic impedance of free space. Yeah, here you can note theta n. Intrinsic impedance of free space is 120 ohm. Okay, yeah. Next, and coming to the point of radian and steradian. Okay, radian and steradian. Mainly, you have to concentrate about the concept. Like I'll show you. Yeah, here. One steradian is equal to one steradian equal to 1 radian square. One steradian is equal to, yeah, here you can, yeah, 1 steradian equal to 1 radian square. Keep this in mind. Okay, wow. 1 steradian is equal to 1 radian square. This what about the 1 steradian and 1 radian square. This what about you have to know what is beam area. So beam area, as you know that pattern of beam area, half of beam width and equal solid angle. Yeah. So before we are going to see about 1 radian equal to 1 radian square, and beam efficiency, you all know that beam efficiency is nothing but the ratio between the major beam area to minor beam area. Okay, beam efficiency is nothing but major beam area to minor beam area, and the stray factor minor beam area to total beam area. Minor beam area to major beam area, total beam area is going to be called as stray factor. And next you have to concentrate about radiation intensity. We have a clear formula for this, and radiation intensity is equal to pi equal to 0 to 2 pi, phi theta equal to 0 to pi u of theta comma d omega. And this is the formula u of average equal to p radiation by 4 pi. And here I told you, yeah, 1 second, I will show you. Yeah, yeah. One second. Yeah, come to the point of gain. Another parameter after radiation intensity, we are going to see about your gain. So gain is nothing but it's defined as the ratio of maximum radiation intensity from subject antenna or antenna under test to the maximum radiation intensity from reference antenna. What is your reference antenna? Your reference antenna is nothing but isotropic antenna. Keep in mind. Your reference antenna is nothing but isotropic antenna. Okay, so the gain is going to be represented as, it is defined as the ratio of maximum radiation intensity from test antenna to the maximum radiation intensity to the reference antenna. Your reference antenna is nothing but isotropic radiator antenna. Isotropic antenna is going to be called as radiation gain. Okay, in terms of power received, the gain is going to be calculated as gain equal to maximum power received from subject antenna to the maximum power received from reference antenna. Okay, maximum power received from subject antenna to the maximum power received from a reference antenna. Again, reference antenna is isotropic antenna that will take for the consideration. Okay, reference antenna. And gain in terms of field strength, it can be defined as the ratio of field strength at given distance from the test antenna in its most forward direction to field strength from isotropic antenna at same distance is going to be called as gain in terms of field strength. Okay, wow. Generally, what is gain? Gain can be calculated with the help of radiation intensity, power received, field strength. Okay, three we have discussed, and we also know about what is directive gain. Okay, wow. Directive gain. It is defined as the ratio of the radiation intensity in particular direction over radiated power. It is a function of angles of theta and phi. Okay, wow. So this one about the directive gain. Similarly, we have the power gain. It can be represented by power density radiated in the particular direction by subject antenna to the power density radiated in that direction with reference antenna. It's going to be called as power gain. Generally, the gain is going to be divided into two types. One is going to be directive gain, and another one is going to be called as power gain. Here they have given the formula for those concepts. Okay, wow. Yeah, directive, and this one how the radiation pattern is going to be existing, and directivity. Now we will see about what is directivity. Okay, yeah, directivity. The resolution of antenna is defined half and beamwidth, first null beamwidth. Okay, wow. So the directivity is going to be represented in the form of, yeah, simply take down this. What is directivity? The directivity of the antenna is going to be defined as it is defined as the ratio of maximum radiation density to the average radiation density of the antenna. Okay, wow. Keep in mind, ma. The antenna directivity is going to be represented in terms of maximum radiation intensity to the average radiation intensity. Okay, wow. That's what about your maximum to average radiation intensity. 1 second. Max, yeah, here you can have directivity equal to maximum radiation intensity to the average radiation intensity. So 4 pi u max by p radiation is going to be called as directivity of your antenna. Simply, the directivity can be obtained with the help of this, and finally we can able to get the radiation as lowest possible directivity of value d equal to 1. All practical antennas have the directivity greater than 1. 1 விட அதிகமா இருக்கணும். ஓகேவா? This is what about directivity, and this is the formula how to calculate the directivity in terms of field pattern, theta and phi. If they have given the field pattern, with the help of this, how can we find out the directivity? Generally, directivity d equal to, where it is? 4 pi by omega a, 4 pi by beam angle, 4 pi by beam solid angle. Here you can give. Represent the directivity in terms of beam area, beam solid angle. So alternatively, we can define directivity as ratio of sphere. While giving the sphere, this is the formula for our finding the directivity. Simply, the directivity d equal to 4 pi by omega a. This is the formula. Okay. While substituting this, we are going to get the directivity of isotropic radiated antenna. Here they have given. 1 second. Directivity of an isotropic antenna. As I told you, your isotropic antenna is going to be a lossless antenna, hypothetical antenna, which will be always taking for the reference. It's not physically realizable. We are going to take. Okay, ba? Yeah. We know that the beam area omega a equal to given that, and finally the beam directivity. We know that directivity d equal to 4 pi by omega a. Here, for isotropic antenna, omega a equal to 4 pi. Here, you can note down this. For isotropic antenna, the omega a, beam solid angle equal to 4 pi. While substituting the 4 pi in directivity formula, we are going to get directivity equal to 1. Understood? So, directivity of isotropic antenna should be 1. Thus, for an isotropic antenna, directivity equal to 1. This is the smallest directivity that an antenna can have for the antenna. Okay. This is the smallest directivity that an antenna can have. So simply you can say that they will ask in GATE exam also, what is the directivity of isotropic antenna? By simply you can say that 1. Answer is 1. Okay. Simply you can say the answer. The directivity of isotropic antenna is equal to 1. Okay, va? So we have seen directivity. So what we have seen so far, we have seen about the radiation pattern, beam solid angle, and what are the lobes available in our antenna, half power beam width, fractional beam width, and we have seen what is beam efficiency and stray factor, and what is radiation intensity, and what is the gain. Gain also we discussed, okay, and what is the directive and power gain also we discussed, and finally we discussed about the directivity of what is directivity and directivity of isotropic antenna. Okay, what is the directivity of isotropic antenna? The directivity of isotropic antenna is equal to 1. Don't forget this. This majorly they will ask the question in the GATE exam. Not only in GATE, wherever we go, definitely they will ask this question. What is the directivity of isotropic antenna? So we all know that what is power gain we discussed, we have seen, and power gain we discussed, maximum power gain also we discussed with the help of the radiation intensity, and also we discussed about the what is gain and what is the antenna bandwidth also we discussed. Okay, so generally what is bandwidth, ma? Generally what is bandwidth? Bandwidth is nothing but the ratio between the upper and lower cutoff frequency is going to be called as bandwidth. Bandwidth over which the gain of antenna is higher than the acceptable value. Bandwidth over which the standing wave ratio of transmission line feeding antenna is below acceptable value. What is standing wave ratio? Can you able to get what is standing wave ratio? Yeah, I'll tell you. It's one of the important concept of antenna. Okay. The characteristics impedance should always equal to the source impedance. Okay. Z0 should always equal to ZC. Z0 is source impedance. ZC is characteristic impedance. If the characteristic impedance is very high, then the transmitted signal is not going to be forwarded. It will be getting deflected back. It's going to be called as standing wave ratio. எப்பமே Z0 ZC equal இருக்கணும். Source resistance equal to characteristic resistance of the in the major area. Once again, yeah. So it's going to be calling us standing wave ratio. Once again, ma, I'll tell you, standing wave ratio is something, but a partial wave is getting reflected back of our source. This is happening when source impedance is not equal to characteristic impedance. That definitely they'll ask you when the standing wave ratio is going to be happening. Okay. So whatever it may be, the bandwidth BW is equal to del W is equal to omega 2 minus omega 1. Omega 2 is nothing but higher cutoff frequency, where omega 1 is nothing but lower cutoff frequency. Okay, it is equal to omega naught by Q. Okay, and Q factor of antenna is given by important question mark. They'll ask in problem Q factor, quality factor. Okay, where F naught is the center frequency or descent frequency or resonance frequency. This later. Okay, omega naught is 2 pi F naught. Omega naught equal to 2 pi F naught by Q, and Q is nothing but quality factor. Quality factor of antenna is given by Q equal to 2 pi 2 total energy stored by antenna by energy radiated per cycle. Okay, once again I'll tell you, quality factor of antenna Q is equal to 2 pi into total energy stored by antenna, by energy radiated per cycle is going to be called as antenna bandwidth. So whatever MMB system we are going to take, definitely we have to know about what is bandwidth. For antenna concept, we have to concentrate over the beam width. How many beam widths are there? Two types of beam width. Fractional beam width, half power beam width. Okay, so bandwidth also an important parameter in the case of antenna, like our beam width. Okay, and input impedance. Input impedance also placing major role in the case of antenna design. Antenna impedance. Okay, it is defined as the impedance presented by the antenna and its terminals. It is defined as the impedance presented by antenna at its terminal. Is going to be called as input impedance. Okay. Next, this is all the way how we are going to find out the input impedance. I'll tell you one thing here. Yeah. Next, I will show you. Yeah. In antenna impedance, we have two types. One is going to be self and mutual impedance. Okay, The impedance of antenna measured at the terminals where transmission line carries RF power connected is called antenna input impedance. These terminals are nothing but feed points of the antenna. The impedance is also called feed point impedance or terminal impedance. Okay, yeah, we can have the two types of impedance. One is going to be called as self impedance and another one is going to be called as mutual impedance. Okay, mutual impedance. Okay, yeah, before we are going to see about radiation resistance, we'll see once again the impedance of antenna. Okay, wow. Once again. Yeah, here you can concentrate. The mutual impedance of an antenna is mainly concentrated over the magnitude of induced voltage, phase difference between induced voltage and input current, and third one, turning conditions of coupled antennas. This is called as mutual impedance. Okay. Next, we are going to see about the radiation resistance. Okay, wow. Generally, the radiation resistance is going to be called as the antenna is a radiating device, as you all know that. Yeah, you know that our antenna is going to be a radiating device. Radiation of what? Radiation of electromagnetic energy, in which the power is radiated into space in the form of electromagnetic waves. As you all know that the power is going to be radiated in the free space by the means of electromagnetic waves. Hence, there may be power dissipation which may be expressed as W1 equal to I square RR. Okay, wow. Here P radiation, power radiation equal to I square R. Power radiation is equal to I square R. Okay, so R equal to power radiation by I square. Okay, wow. Yeah, and in radiation, the radiation resistance of a 50 ds resistance generally, and the radiation resistance only kadayadu. With the help of radiation resistance only, the antenna can radiate the energy into free space. That's why your radiation resistance is going to be called as 50 ts resistance. Keep in mind, ma. What do you mean by 50 ts resistance? And find out the value. Okay, the radiation resistance is a 50 ts resistance such that when it is connected in series with antenna, dissipates same power as the antenna actually radiates. Okay, wow. That's what about your radiation resistance. Okay, wow. Next. So as I told you, we can have the two types of beam width. One is going to be called as first null beam width, or we can call it as beam width between first null. As I told you, so in our antenna radiation pattern, we can able to find out two types of lobes. Is it not? One is going to be called as main lobe. Another one is going to be called as minor lobe. The minor lobe is going to be categorized in two types. One is side lobe. This one is going to be called as side lobe. And back we can have the main lobe of your main lobe back lobe on the back lobe. Main lobe பின்னாடி இருக்க lobe வந்து back lobe. அதுக்கு பக்கத்துல இருக்க lobe வந்து side lobe. Side lobe and back lobe. These two are going to be constitutes our minor lobe. Major lobe, we have two types of beam width, half power beam width and half power point. Okay. So first null beam width or beam width between first null, we are going to be starting from the origin to origin. This area. Yeah, can you able to see this? This area is going to be called as first null beam width. And how we are going to find out the half power beam width? From the maximum radiation to, we are going to take the 3 dB. The 2 points will cut in the major lobe. That area is going to be called as half power beam width. This is about the half power beam width. Here we have the half power point left, half power point right. This is about the area of half power beam width. This is the area of first null beam width. Okay, wow. And now come to the point of half wave dipole, that we will see later. Okay, with the help of this concept we will see later. And also we discuss what is radiation distance and what is radiation pattern and gain directivity, front to back. Yeah, it's very important, front to back ratio. Yeah, the FBR, front to back ratio, is given by power radiated in desired direction. Power radiated in desired direction to the power radiated in opposite direction is going to be called as front to back ratio. Front to back ratio. Okay, wow. This is all about the basic fundamental concepts of antenna. Okay, wow. Next we are going to see about. Yeah, can you tell me what is front to back ratio? The ratio, the front to back ratio is going to be called, is going to be measured in terms of power radiated in desired direction to the power radiated in opposite direction. Is going to be called a front to back ratio. Okay, as you know that basal lobe and minor lobe also we discussed, impedance also we discussed. Yeah, we'll see some sort of problem later on. Next class full of problem pakla. Before that we'll see some problem. Okay, va? For a dipole, what is the major factor? Yeah, here we will see about a dipole antenna is a linear antenna usually fed in the center and proceeding maximum to radiation in the plane normal to the axis. It's said to be short dipole when length is less than lambda by 4. Clear? When dipole is having the length is less than lambda by 4, it's going to be called as short dipole. Okay, va? When length is going to be exactly equal to lambda by 4, it's going to be called as ordinary dipole. So apart from that, we have one more dipole is going to be called as Hertzian dipole. Hertzian dipole ki length vandu greater than 4, greater than 10 ku less than 4 ku irko. That's going to be called as Hertzian dipole antenna. Radiation intensity is maximum along the normal. Yeah, this is our main point. Keep this point in mind. Radiation intensity is maximum along the normal to the dipole axis. So the option A is going to be existing. Okay, this is one of the gate question they asked in 1994. Okay, one more question. And the antenna when radiating has highly directional radiation pattern. When the antenna is receiving its radiation pattern. Okay, an antenna is a reciprocal device, as you know that, whose characteristics are same when it's transmitting or receiving. Okay, whenever it's going to transmit the electromagnetic energy and whenever it's going to receiving the electromagnetic energy, the antenna will do the same work. That's what about your antenna concept. Thus, an antenna when radiating has a highly directive radiation pattern. The receiving antenna will also have the same pattern. Yeah. Antenna வந்து radiate பண்ணும்போது எது மாதிரி இருக்கோ அதே போல தான் receive பண்ணும்போது இருக்கும். For that, you have to mainly concentrate about the polarization concept. Okay, wow? That's very, very important. Okay, next. Yeah, the radiation resistance of a circle loop of one turn. Yeah, this we'll see later, ma. Next topic we will see this concept. Yeah, here you can see an antenna in free space receives 2 microwatts of power when the incident electric field is 20 milliwatts per minute RMS value. The effective aperture of an antenna, effective aperture, we can have the formula effective aperture AC equal to PR by PD. Okay, we have separate formula for PD equal to E square by N. E square value is 2 into 10 to the power 3, 20 microwatts. Yeah, 20 microwatts 2 into, so that we will get PD equal to 1.061 into 10 to the power 6 watts per meter square. Power received 2 microvolt. Yeah, 2 into 10 to the power minus 6. So by applying PD to PR, மேல வந்து PR 2 into 10 to the power 6, கீழ வந்து PD 1.06 into 10 to the power 6. So that you are going to get the effective aperture is equal to 1.88 meter square. So the option C is going to be effective. Okay, wow? So this is what next problem. The far field of antenna varies with the resistance of R as R equal to 1 by R. Yeah, R equal to 1 by R. Option A is going to be right. Okay, 1 by R. Okay, this is what about this concept. Yeah, here if a diameter of a lambda by 2 dipole antenna is increased from lambda 100 to lambda 50, then its beam width increases or its gain will be increases. Okay, wow? The gain of the antenna will be increasing. So whatever it may be, by increasing the diameter of the dipole, generally whatever it may be, generally While we are going to increase the diameter of the dipole antenna, we are going to increase the gain. So mainly we are concentrating over the gain and we are going to get the increased gain in terms of this concept. Okay, va? So today we have seen only the basic concept. Yeah, basic matda paathom. By next class, we will discuss about how your dipole, monopole, and linear antenna concepts. Can you get it, ma? So we are going to see about basic fundamentals. So today we have seen about what is basic fundamental and few concepts, few problems we discussed about this concept. Okay, va? That's what about your. Generally, we have discussed about what is antenna, and before we are going to discuss about what is antenna, we discussed about what do you mean by wireless communication and wired communication. So in case of wired communication, definitely there should be a chance of connecting devices, proper channel between the sender and receiver, between the transmitter and receiver section we can have. Okay, va? So that's what here. So next we have discussed about your the wide variety of concepts of cables. Yeah, single line cable, parallel cable. We discussed about single wire cable and parallel cable. Then later we discussed about twisted pair. What is the main drawback in the case of twisted pair cable? The main drawback of twisted pair cable is going to be called as crosstalk. Later on, we use the coaxial cable and fiber optical cable. Okay, these are all the concept of wired communication. While coming back towards wireless communication, so in wireless communication, definitely we have to use the antenna concept. Okay, so consider that we are going to use the satellite communication. So you all know that the distance between the transmitter and receiver of your satellite, the transmitter is available in Earth, where your receiver is available in the sky, about the distance of 36,000 kilometers. Can you able to connect with the wire? No, it's not possible with the help of wired communication. Okay, va? It's able to possible with the help of this wireless communication. Yeah, with the help of the proper antenna, we are going to transmitting the signal towards your satellite. While receiving the satellite the signal, and it will propagate towards where it required. Whichever devices are required, those signal is going to be received. Okay, va? It's going to be repropagate from your transmitter. Okay, from your satellite. As you know, that satellite is going to be repeating device. Okay, va? So with the help of satellite communication, we can able to transmit the signal for a long distance communication. Similar like our mobile communication. Ultimately, mobile communication, we are going to use this concept of antenna concept. Okay, va? So this is what about we have seen. What is we have discussed about your antenna concept. Generally, whatever the topics we have, simply whatever things I am telling you, just note down. Your antenna is something but ordinary elevated conductor which radiates and intercepts the electromagnetic energy. Your electromagnetic energy is nothing but having both electric and magnetic field perpendicular to both each other and 90-degree phase shift between the wave motion. It's going to be called as electromagnetic energy. Okay, next. So this is what how we are about your standing wave. I told you what is standing wave. When source impedance is not equal to characteristic impedance of your transmission line, by the time standing waves will be existing. Okay, that you should keep in mind. Okay, and this also we have discussed how we are going to transmit the signal and how we are going to receive the signal. With the help of generator, we are going to transmit, and with the help of the receiver, we are going to receive the signal. And this is what how about your electromagnetic waves are going to be existing. That's what. And in between, our intrinsic impedance of free space equal to 377 ohm or 125. They will frequently ask you. With this value only we are okay. And we all know that functions also we discussed. It's a radiator, sensor, transducer, and impedance matching and coupler device. What is coupler? I told you. Coupler, balloon, balancing and unbalancing unit is going to be called as coupler. And we all know that we have wide variety of application. We can use this antennas for Wi-Fi, Bluetooth, and satellite, mobile communication, wherever we use the wireless communication concept, definitely your antenna placing a vital role, as I told you. And I told you we have discussed the major points, major important points of your antenna parameters. Okay, radiation pattern, beam solid angle, radiation intensity, beam width, gain, directivity, impedance, and radiation resistance. Polarization, yeah, I forget to take about polarization. I'll take next class, and effective aperture also. Yeah, these three topics I couldn't take you. I'll take it by next class. Okay. Till that we have covered. Clear? So radiation pattern, beam solid angle, radiation intensity, beam width, gain, directivity, impedance, and radiation resistance. Apart from that, bandwidth also we have discussed. Like the beam width, bandwidth also we discussed about the antenna concept. These three topics we'll discuss by the next class. Okay. These are the concepts we discussed today. And apart from that, we discuss about what is the simple antenna, like our isotropic radiator, direction antenna, and non-direction antenna. Okay, for isotropic, I tell you just to keep in mind, it's an antenna designed as hypothetical lossless antenna having equal radiation in all directions. Okay, and direction antenna is the one having the property of radiating and receiving wave efficiently in some other direction than the other direction. And coming back to the non-directional, or we can simply say it as omnidirectional antenna, which will radiate the energy towards a particular direction. Okay, and also we discussed about the pattern lobes. Okay, pattern lobes is a portion of the radiation pattern with a local maximum. Lobes are classified as major lobe, minor lobe, side lobe, and back lobe. Okay, major lobe, minor lobe, side lobe, and back lobe. Generally, side lobe and back lobe is going to be called as minor lobe. We have the major lobe, which occupies major area in the graphical method. Graphical pattern is going to be called as major lobe. And minor lobe, we can have the side lobes and back lobes. Yeah. Apart from that, we discussed about what is radiation pattern, and the patterns also we discussed, and we have discussed about beam width, fractional beam width, and half power beam width also we discussed. And we discussed about what is field pattern, power pattern, what do you mean by this one, radian and steradian. Okay, okay. The angle defined by the circular is going to be called as radian. The angle defined by the sphere is going to be called as steradian. So 1 steradian is equal to 1 radian square. Don't forget this. 1 steradian is equal to 1 radian square. Okay. Next, we discuss about the beam width and radiation intensity. P radiation by 4 pi. It's a major function. And directivity also we discussed. Yeah, directivity D equal to 4 pi by omega A, beam solid angle. 4 pi by omega A, beam solid angle. Okay. Directivity in terms of angle given, theta and phi, 41253 by theta and phi. And we discussed about your 1 second. Yeah, and also we discussed about the directivity of isotropic radiator. We discussed about your isotropic radiator directivity. What is the directivity? Directivity is equal to 1. Don't forget. Yeah, for isotropic antenna, yeah, for isotropic antenna D equal to 1. This is the smallest directivity that an antenna should have. Okay, so this we discussed. Then power gain also we discussed. Gain and directivity both we discussed. Impedance also we discussed. Resistance also we discussed. Beam width also discussed. Half power beam width and fractional beam width. Yeah, front to back ratio is the important concept of antenna. Front to back ratio. Impedance also, and few of the problems we discussed on this topic. And most of our problems we also discuss in the next class. Okay, these are the basic parameters and concept of basic antenna. Yeah, these many parameters we discussed today. We'll see the 3 more parameters with the next class. Apart from that, we'll discuss about the dipole, monopole, and linear antenna array concept. Okay, by antenna. And few of the problems also we discussed. Okay, these are the concepts. So these are the concepts, these are the formulas, these are the values what we obtain. So from this, they will ask the gate questions. Not only gate question, wherever you go, definitely as an EC student, they will ask the question from antenna. They check your ability. Okay, especially while you're going for your core oriented company. Okay, with this, we can plan for the next class. Okay, thank you for attending the classes. Okay, thanks for coming to classes. By next class, we'll see the concepts of 3 more concepts and topics of our syllabus: dipole, monopole, and linear antenna patterns. Okay, that thing we'll see by the next class.